Okay, this is the little meter that we're going to be using. This is my own personal. It's not like the ones that we have at the lab back at St. Philip's, but it'll do for what we need. I just want to introduce you to it and some of the functions we'll be using. We can turn it on there, and you can see it immediately goes to overrange because we're on the 200 ohm setting. And right now it's open, so any of these ohm settings will be overrun. I can show you. I can put it on the 120 on this this here. It's a little intermittent. It shouldn't be that. Let's turn it around. See if I can make better contact. 121, 120.2, 121. I'll get better measurements in a little bit. So you can see that it does measure anything below 200. This is anything below 2,000. This is anything below 20,000. Here's 200,000 ohms, and here's 2,000 kiloohms, or 2 megohms if you want. Let's see if I said that right. 200 ohms, 2,000 ohms, 20,000 ohms, 200,000 ohms, and 2 million ohms it'll measure. All of those it's overrange. That's why it only shows the one. Then, so that's our resistance area. Then this is DC volts, 200 millivolts, 2,000 millivolts, which is the same as 2 volts, 20 volts, 200 volts. You can see that the decimal place keeps moving over, and 1,000 volts. Believe me, I won't go anywhere near 1,000 volts. And then AC voltage is 750. You can do 200. Your wall socket will be 120. So I don't recommend you go sticking things in the wall socket, but if you know what you're doing, you would read 120. Then this is a battery checker. I've got 2 batteries here. It says there for a 1.5 volt battery, it should read 4 milliamps. And so let's get the polarity right and check that battery. Oh, my hand's covering the that battery. Hello. Why isn't it? I just checked it a while. There it goes. 4.1. There's 4.1. All right, let's check it on this one. Should give 4 milliamps. It's intermittent, but it's there it goes, 4 milliamps. So it's just a battery checker. And then we go to DC amps. Now that's 200 microamps. This range is 2,000 microamps, which is the same as 2 milliamps. This is 20 milliamps. This is 200 milliamps. And if you really need some high current, the 10 amps, which is a dangerous current, I wouldn't attempt measuring 10 amps, but they have it available. You would switch it over to that little socket. HFE is a transistor gain setting. So you can see here there's a for an NPN transistor, you have the emitter base collector, and on the PNP you have emitter base collector. You would use this HFE to measure the gain. Then you have a diode setting. Okay, the HFE, that's for the transistor. This is a diode setting. I have a diode here. In one direction it'll show like it will show open, and in the other direction it'll show flow. So in one, let's see, in this direction it shows, you know, three something, but basically it shows flow. If we reverse these, it shows open. And so that's the nature of a diode. It allows current in one direction, but not in the other. It's for protection. It's a protection circuit. And then we get back to the resistance, 200 ohms. So we've gone full circle around the meter. And let me see if I can show you a close-up, just so you see all of these devices. I might photograph it and post it on Canvas. And that's it for this this session.